Let's do item 5 of WAKISSHA, paper 1, Math 2026. This is senior 6. Item 5, a local paint company manufactures specialized industrial coatings, and this production profit function over time T years is modeled by, this is the P, the T is equal to 0.04 P into 1 minus 0.02. After the first year of operation, the company recorded, so T is equal to 1. The company recorded a profit of 500,000. This is the profit, 500,000. That is the profit. Then management forecasts that in 5 years, the profit will reach 2 million, but they are not sure. Now, before you proceed, because we are going to get, this is a DE, let us first see. Let us first simplify the right-hand side, and we see what we have. I'm seeing 1.01 minus, I don't know what the examiner wanted here, but okay, let's do it the way it is. 1 minus 0.02 times 0.04. dp dt is equal to, if I combine this and this one looks funny, I will have 0.0392 p. Then this one I'm going to just separate variables. It is also dE. So I'll bring the p this way. I have dp over p is equal to 0.0392. The dt has gone this way. Then I integrate both sides. This will give me the natural log of p, which is equal to 0.0392 t plus a constant of integration, but they give us conditions. When t is 1, p is that. So I'm having ln of 500,000 is equal to 0.0392 times 1 plus c. So my c value is going to be ln 5 exponent 5 minus the answer. And this C value is going to be 13.0832. So after getting the C, you get it and put it back here. And I'll have ln P is equal to 0.0392 T plus C, which is 13 point. Those that learned how to store, it is very good for you to store such work to avoid errors. So they said that they wanted to see if in the next 5 years it will reach 2 million. So when t is 5, when t is 5 years, we want to see if our p is going to be 5 million. So I just substitute. I say ln of p is equal to 0.0392 times 5, then plus my c, which is 13.0832. So I'm saying that answer that I already stored plus 0.0392, then times 5. I have ln p is equal to 13.2792. Then for me to get p, I introduce exponential on both sides. Ln p is equal to exponential 13.2792. Exponential natural log gives you a 1, so it becomes p is equal to, if I say exponential of the answer, I'll have 548, then 880. And this is too low. So the shillings or the UDX, therefore, it is, how should I conclude? They said, by the I'm doing part here, Roman numeral 1, help the company know whether the project profit growth target is achievable. It is not. It's not even halfway. Since 548, this is far less than the 2 million UGX. Then I'm saying it's not achievable. It's not achievable at all. Then we proceed. The same item continues and it says that the package, to package the paint, the company designs a container made from square sheet of reinforced plastic measuring 60 by 60. The corner is formed by cutting squares of side Y from each corner and folding folding the sides upwards. There is a square which is here, so it is having equal dimensions, but they have said that they cut off Y. So if they cut off Y at all the corners, this corner they cut off Y like this is Y. Then this corner you also cut off Y. This is Y squares. Then this side, each corner they are cutting off Y. Even this corner they are cutting off Y. So meaning that what we are going to have is something like this. That is having corners being cut like this. Then also here, like that. That is what we shall have. Then after cutting off all the corners with a dimension of Y squares, they fold it. So when they fold this one here like this, if it has been cut off like this and now they fold, they are going to form, this is going to fold like this, and this one folds like this, and it is going to form an open box. When it forms an open box, our open box that is going to be formed is going to have, if I'm to draw it out, just I'm to draw it out, you can even try it at home and cut off similar edges, and then you try to fold this is going to form an open box. Now they told us initially that it was measuring 60 by 60. Initially the whole of this was 60. Even here it was 60. They are meters, sorry, they are centimeters. Now, if you look at this side, they removed the Y here in this corner. They also removed Y in this corner. So the new formed box is going to have a length which is going to be 60 minus 2Y. The same thing when you look at even this side, if this is the length now, if you look at the width, it is 60, but they took off a Y like this. This one is a Y from here. They also took off a Y. So it is also going to be 60 minus a 2Y. But now the height, when you fold it like this, its height is going to be the distance from here to here. This is going to be its height. After folding this one here like this, that thing that is going to be standing is going to be just Y, which is here. Now, having seen that, they say that the container is formed by cutting that we have seen. For efficient shipping, the container requires a container with a maximum volume. So we are going to go ahead and find the volume, and they are saying the volume should lie between 15,000 and 18,000. Let us get the volume of this. Volume is given by, now it is no longer, it's not a tube, it's a cuboid. So it is length times width times height, because the height is Y, unlike the others. The volume is length, which is 60 minus 2Y into 60 minus 2Y, then times the height, which is Y. Now, time to open brackets. This is like saying 60 minus 2y squared, and we are going to use this expansion. I'm sure my viewers know this expansion. A plus b squared is equal to a squared plus twice the product of ab plus b squared. So it is what I'm going to use, and I'm squaring this, which is 3600 minus twice the product of this. So this is going to be 60 times 2, which is 120 times 2 gives me 240 y. Then I square this plus 4y squared. Then I multiply with the y. Then meaning that my volume is going to become 3600y minus 240y squared, then plus 4y cubed. But now they talked of having a maximum volume, so I need to go ahead and differentiate. Now I'm differentiating dv dy. Some people are used to differentiating dy dx. So dv with respect to y, because now the term is in y, I'll have 3600 minus the 2 drops, and it multiplies with this, so that is 480. Reduce it by 1, you stay with the y. Then when the 3 drops, it multiplies with the 4, gives you plus 12y. Reduce it by 1, you stay with the 3. So we said that if they want maximum volume, for volume to be maximum, our dv dy should be equal to 0. Did they say maximum? Let me check and see. Yes, maximum volume. Then it says 0 is equal to 3600 minus 480y plus 12y squared. I see I can divide through by 12. If I divide by 12, I have y squared plus. If I divide 480 divided by 12, I have a 40, which is a negative. I'm starting writing from this side, but everything is transferred this way. So it's a negative 40. Y then 3600 divided by 12 will give us a positive 300. But this is equal to 0. Then this is a quadratic equation which I can solve. Y is equal to negative b, which is 40, plus or minus square root of b squared. Avoid just putting values without substituting. Minus 4 times a, which is 1, then times 300 over 2 times 1. I can go to my calculator. I go to equation degree unknown degree 2. Then I choose a is 1, b is negative 40, then c 300. And now my first y value is 30 centimeters. The second y value is 10 centimeters. They asked for dimensions, and dimensions are supposed to be between 15,000 and 18,000 cubic centimeters. I've got dimensions, but I don't have the volume, so I need to go ahead and find the volume. How do I get the volume? Of course, I start by getting which one will give me the maximum volume, by the way. Which one will give me the maximum volume? If I use y is equal to 10, this is going to give me, I need to get the second derivative to see which y value gives the maximum. So testing for, I want to test to see which one is the maximum value. Is it 30 or 10? So if I test, I get the second derivative. This is going to be the squared v dy squared, which is equal to, this goes to 0. So this is the negative 480. Then plus 24y. Now I'm going to test with a 10 and a 30 to see which one gives the maximum, such that I use that dimension to get the volume. So I'm saying the squared v dy squared, when the first y value that we have, let me start with a 10. I substitute. I've said it is going to be a negative 480 negative 480, then plus 24y. 24y times 10. This is going to be negative 480 plus 240. It's a negative 240. Automatically, this gives us a maximum because we said if this squared v y squared is less than 0, then it will be a maximum. Then if it is greater, this squared y, sorry, this is the y squared. If it is greater than 0, then it will give minimum dimension. But let us test, all of them might be giving maximum. So I'm saying this squared v, the y squared, when y is equal to 30, we substitute and say that is 24 times that gives us a positive 240. This positive 240 they are giving us indicates a minimum volume. So instead of using 30, I'm going to use 10 because it is the 10 that gives the maximum. Now, I substitute in the form of getting the volume. We say that volume is equal to our length, which is 60 minus 2y. 60 minus 2y. Where did we simplify it from? We have 3600 times y. We are using 10. Then minus 240 times 10 squared, then plus 4 times 10 to the power 3. I get my calculator 3600 times 10 minus 240 times 10 squared, then plus 4 exponent 3. So my Vmax will give me 16, which is in the between. Now, what about a learner? Let me first. What about a learner who uses 30? Because someone might say, I've got 10 centimeters and 30 centimeters. Automatically, 30 will give me the maximum. No. If we test by 30, let us test and we see. So it will be 3600 times wherever there is 10, I'm putting 30, then minus 240 times. Now we are squaring a 30. That is where the problem is. Plus 4 times we are cubing a 30. 30 power 3. 30 power 3 is giving 0. Even if we even didn't bother so much, just getting 30 and you put here 2 times 30 is 60. 60 minus 60 gives 0. So even if you multiply, you'll get a 0. So it is not the size of the value that gives the maximum, but rather you're supposed to test by using the second derivative. Now, the question was saying that Roman numeral 2, help the company know whether the container design meets the required volume standards. Yes, this is Roman numeral 2. Yes, it meets. Why? Because it is in the range of 1,500 to 1,800. Between the range of 15,000 and 18,000. So that is correct. Then finally, the company also contracts a specialized firm to produce a spherical metallic canisters for sample batches. During the manufacturing process, a 1.5% measurement error occurred in the radius. This must be part B. So our delta R over R, it is a percentage error. It is 1.5%. According to the industry safety guidelines, any canister with a volume error exceeding 5% will not be certified for distribution. Will the spherical metallic canisters be certified for distribution? So we have the percentage error made in measuring the radius. Then we are supposed to test and see the error made in the volume if it does not exceed 5. Volume of the sphere, spherical, it is 4 over 3 pi r cubed. This is under small changes. So under small changes, we shall say small changes combined with errors. We are looking for delta V over V, percentage error in measuring the volume. It shouldn't exceed 5%. So for us to get this, we need to first get the full derivative dv dr, which is going to be 4 pi r squared. We said you drop the 3, reduce this by 1. Then the next thing we are going to do, for small changes, the delta V over delta r always approximates to a full derivative dr. So since I want to get delta V in my final answer, I stay with delta V this side. I'll approximate it to dv dr, which is the full derivative times delta r. The delta r has crossed the other side. Then I substitute for dv dr because I have it. So I'm having delta V approximating to dv dr, which is 4 pi r squared, 4 pi r squared times the delta r. But my question, I'm looking for delta V over V. So here I divide by V. Then this side I divide by the formula for V, which is 4 over 3 pi. Here I divide by V. To strike a balance, also I divide by V. But now I put the formula. While dividing by V, I want to get delta V over V. So this is 4 over 3 pi r squared, which is the formula. So it is pi r cubed for the volume. 4 cancels, the 3 goes up, pi goes, r, 2r squared goes, I stay with r in the denominator. So when you look at this from here, delta V over V approximates to 4 is out. I'm saying the 3 has gone in the numerator, dividing a fraction in the denominator. Then I've stayed with the delta r. Since here I have r cubed and here I have r squared, so here I'll stay with the r in the denominator. But according to what we are given a 1.5 as a delta r over r. So this is the chapter whereby things just work out like magic. This is 3 times 1.5%. This will give me the percentage. So when I compute my delta V over V, actually it is just approximates to a 4.5%. But they wanted us to prove, will the spherical metallic canister be satisfied for distribution? I'm saying yes. Why? Because the error made in making the volume is less than the 5%. Because they said if it is less than 5%, then the canister can be produced. So thanks for watching. We meet in the next mock body.